take up another question. Okay. That is question on the viscous flow. So crude oil of relative density 0.9 is pumped through a smooth horizontal pipe 400 meter long, 100 mm diameter, 100 mm dia. The kinematic viscosity 2.5 stock. Differential pressure head between 2 ends of pipe is 16.31 meter of wide. Assuming the flow to be laminar, find rate of flow of wire. Number 2, power required to maintain the flow. This is the question, and check whether the flow is laminar or not. This is the question. Okay, so question is lengthy. So let us collect the data. First, crude oil of relative density. So specific gravity 0.9. So from here, mass density is 900 kg per meter cube and weight density is 900 into 9.81 in Newton per meter. Weight density and mass. Through a smooth horizontal pipe, 400 meter long. So length is 400 meter. Dia is 100 mm. Okay, so it is 100 divided by 1000. It is 0.1 meter. Kinematic viscosity nu. So nu is equal to mu by rho. Okay, so that is 2.5 stock. Here it is not the standard unit. As kinematic viscosity, absolute viscosity is given in twice. Kinematic viscosity will be given in stock. So it has to be converted. This stock is nothing but centimeter square per second. So we have to convert this value. So 2.5. Okay. So nu will be 2.5 into 10 raised to power minus 4. Then it will have meter square per second. Okay. Centimeter divided by 100. So it will be multiplied by 10 to the power minus 4. So this is meter square. But we will be using, this is nu. Remember, we have to find out mu. So mu will be equal to by cross. So that is nu. Nu is 2.5 into 10 to the power minus 4 into mass density. So mass density is 900. So it is, this value will be 0.225. It is Newton second per meter. Okay, this is the value given, and between the two ends, put pressure difference. So P1 minus P2 is 16.31 meter of Y. Okay. So now this is the data given. Okay. So power required to maintain and the rate of the flow of the Y we have to find. These are the data given. So first of all, equation HF is equal to 32 mu V L by gamma d square. This is the Hazen Poisson equation. Head loss we have to find out. Okay, so how to find out this one? HF is given. So head loss. How much losses? 16. Head loss is actually 16.31 meter. So head loss is given already. So 32 into mu is 0.225. Velocity is not given into L. L is nothing but here 400. Okay. So length is how much? 400 meter. Divided by gamma. So gamma is 900 into 9.81. Gamma d square is 0.1 whole square. So from here we can find out velocity. And from this equation we will get 0.5 meter per second. So discharge number 1, rate of flow, Q will be area, that is pi by 4, 0.1 square into velocity is 0.5. Okay, so this will have 3.92 into 10 to the power minus 3 meter cube per second. Since they are giving liters per second, so we will also convert this into 3.92 liters per second. We are giving this value. Okay. So 3.92 liter per second, first part. Second part, power required to maintain the flow. So power will be gamma Q, that is HF. Okay, so gamma is here. Gamma is that is what density 900 into 9.81 into Q is here 3.92 into 10 raised to power minus 3. So gamma Q, H is nothing but this one. So HF is given 16.31. So it is 16.31. This will have 565.5 watt. So this is the second part of your answer. So first part was discharge. This is the part of your answer. Q is this one. And third part, see, rate of flow of the wire we have found out. Power required to maintain the flow also we have found out. Now check the flow is whether laminar or not. So RE is equal to rho VD by mu. Okay. So rho is here we have found out 900. Velocity also we have found out 0.5 and D is 0.1. Okay. So rho VD by mu is, mu also we have found out, that is 0.225. So this will have the value 200. So RE is less than 2000, flow is laminar. If the flow is more than 2000, then it cannot be laminar. So condition of the Reynolds number is for the laminar, it should have less than 2000. Value of RE we have to find out. So that is rho VD by mu. Putting those values we will get 200. Okay. So let us conclude how we have solved this question. Crude oil of relative density 0.9, that is 9, so mass density and weight density we have found out. That length is 400 meter length. Okay. And kinematic viscosity 2.5 stock. Okay. So stock is not the standard unit, we have to convert it. So mu is equal to mu by rho, and this is stock given. So stock will be centimeter by second, but we have to convert it into meter per second. Okay. So that we have to multiply with 10 raised to power minus 4, and from this equation mu will be this value, this will be Newton second per meter square. Pressure difference is given. Okay. That is differential pressure head. So differential pressure head is nothing but P1 minus P2 is equal to 16.31 meter. Now HF is equal to, this is Hazen-Poiseuille equation. We know that one. Hazen-Poiseuille equation is 32 mu V L by gamma d square. So putting all the value, we will get the value of V, that is this one. So discharge will be area into velocity. This is, answer is this one, but we have to convert it into liter per second because most of the discharge given in the question is liter per second. So that we can leave answer at this place also. So pressure will be, not pressure, power will be equal to gamma Q H. So gamma is given, Q we have found out, HF is also given. So this is almost 565.5 watt. Now in this question it has been also said to check whether the flow is laminar or not. So to check the laminar flow, we have to use the formula RE is equal to rho Vd by mu. So substituting that value, we will get 200. Since this value is less than 2000, so we can conclude that flow is laminar. Okay, so we have solved the numerical of this. Rest of the question I will solve in next chapter. Thank you.